All right, so let's do the rest of them. Let's do 13 through 25. So now you've got to fill in everything here. And we have some polyatomic ions that you're going to focus on. So if we look at the first one, it says aluminum and nitrate. Now aluminum is just normal old aluminum right off the periodic table. So you look on the periodic table, you realize it's in group 3, so it makes a +3 charge. But then we have nitrate. Now 8 ending tells you it's a polyatomic ion. It tells you it's not just nitrogen, but it's nitrogen bonded with oxygen. You have to learn, hopefully by memorizing, how many oxygens. In this case, it's 3, and it makes a -1 charge. This has to be memorized, or you have to look this up. The periodic table does not tell you what this does. So we're going to crisscross the charges, just like we normally do. The 3 is going to go after the nitrate. The imaginary 1 is going to be down here. So we write Al, imaginary 1, and then you write nitrate. Now nitrate and O3 are glued together. They never, ever, ever come apart. But you're going to put another 3 after it to say that we want 3 of these nitrate groups. Now we don't want 33 oxygens and 1 nitrogen. We want 3 nitrates. So put nitrate in parentheses. So this is called aluminum and then nitrate. Cool thing about polyatomic ions, you don't have to worry about changing any endings. It's just aluminum nitrate. But now, what if aluminum hooks up with nitrogen? Aluminum's still making a +3 charge, but nitrogen is right off the periodic table. It's plain old N. Now, if you look at nitrogen on the periodic table, it's in group 5, which means it's got to get 8 electrons, so it needs 3 more. So aluminum's saying here, I got to get rid of 3 electrons. Take these 3. And nitrogen says that's perfect because I needed 3 more in the first place. So 1 aluminum can hook up with 1 nitrogen. It's a 1-to-1 ratio here. They make each other happy. So this is aluminum, and it's not nitrate. It's not a polyatomic. It's right off the periodic table, so it's nitride. Remember, the "ide" ending usually indicates it's off the periodic table. All right, sodium hooking up with chlorate. Sodium's +1. You look on the periodic table, always makes a +1 charge, says here's my 1 electron, take it. And chlorate tells you it's not chlorine. It's not chlorine. That 8 ending tells you it's chlorine hooked up with some amount of oxygens. The only catch is you don't know how many unless you memorize it or look it up. But at least you know it is a polyatomic because of that 8 ending. It gives it away. So anyways, you look up chlorate and it's ClO3 with a -1 charge. So here's the deal. Sodium says take 1, chlorine says that's, or chlorate says that's perfect because I need 1. So they can hook up on a 1-to-1 charge or ratio. Notice that there's no parentheses. It's NaClO3, and this is sodium chlorate. Oops. This is different than chloride because you got that oxygen in there. 8 ending tells you oxygen's bonded to it. All right, calcium's hooking up with sulfate. Calcium, you look on the periodic table, it's in group 2, so it makes +2. It says here, take my 2 valence electrons. And sulfate, 8, not ide, 8. So it's sulfur with oxygen added to it. How many? Well, you just have to look this up or memorize it. Sulfate is SO4, -2. It's always SO4, and it always has to gain 2, which makes it a perfect partner for calcium. Calcium says, take my 2, and sulfate says, that's perfect, because I need 2. So they can hook up on a 1-to-1 ratio. And it's Ca and then SO4. Calcium, sulfate. Notice there's no additional subscripts written here because it's a 1-to-1 ratio. The 2 and the 2 cancel out. And there's no parentheses because we're not writing a number after a polyatomic ion in this case. All right, ammonium. Ammonium is unique because it's one of the positive ions that you'll come across. You're not going to come across many, but there are a couple out there. And this is the positive one that you're going to have to know for now, NH4 +1. So this means 1 nitrogen and 4 hydrogens are all hooked up together, and they need to get rid of 1 electron. They need to give it away so they can stay together because they have 1 too many. Now this is hooking up with chlorine. Chlorine is right on the periodic table. So you look up chlorine. It's in group 7. It's got to get to 8, so it's going to gain 1 electron, which is awesome because ammonium is trying to give up 1 electron. So ammonium gives up 1, chlorine takes it. They make a perfect match, 1-to-1 ratio. Notice no parentheses, no additional subscripts. The N, the H, and the 4 are there, but there's no extra subscripts written anywhere because it's a 1-to-1 ratio. So this is ammonium and then it's chloride, because it's right off the periodic table. It's not a polyatomic, it's just normal old chlorine, so we change the ending to chloride. All right, aluminum, +3, hooking up with hydroxide. Now this ends in "ide," but it doesn't matter. It's one of those polyatomics that should be in your brain. Immediately, you should recognize that, not as an element on the periodic table like all the other ides, but as a polyatomic. So aluminum says, here, take my 3. Hydroxide says, I can only take 1. But if there's 3 of us, OH with a 3, then we can all take 1 electron, and we can hook up on a 1:3 ratio. Now notice that hydroxide has to go in parentheses. If you don't have the parentheses here, then it's going to be 1 O and H3. That's not right. We don't want 1 oxygen and 3 hydrogens. We want 3 sets of OH. So aluminum, hydroxide. Now aluminum is going to hook up with sulfur, +3. Sulfur is not sulfate. It's right off the periodic table, normal old sulfur. It's in group 6. It needs to get to 8, so it's going to gain 2. So aluminum says, here, take my 3, and sulfate says I can't take all of them. I can only take 2, but we can work out a ratio. We can crisscross the charges and learn that Al2S3 is a perfect ratio for these 2 ions. So they're going to hook up on that ratio and form aluminum sulfide. Now potassium, group 1, so it's +1 charge, is going to hook up with sulfate. Not sulfur, sulfate. So you know it's sulfur with some amount of oxygens bonded to it. How many? 4. The only way you know that is if you memorize or look it up. So sulfate's going to gain 2 electrons. So little potassium says, here, take 1. And sulfate says, but I need 2. And potassium says, all right, I'll go find a friend. So there's 2 potassiums hooking up with 1 sulfate. How do you know that? You crisscross the charges. Now notice there's no parentheses after the sulfate because I'm not writing an additional number after it. There's no extra subscripts written after sulfate. There is one after the potassium, but that's not a polyatomic ion, so it doesn't matter. It's only if you write one after a polyatomic ion that you put the polyatomic in parentheses. So this is just plain old potassium sulfate. All right, if potassium hooks up with sulfur, this is regular old sulfur right off the periodic table. Crisscross the charges, it's K2S. Potassium sulfide. Right off the periodic table, ide ending. Same thing here, we got magnesium hooking up with phosphorus, right on the periodic table, and phosphate. Magnesium hooking up with PO4 -3. 8 ending tells you it's a polyatomic. So this is going to be Mg3 PO4, and you're going to write a 2 after it, so the PO4 has to go in parentheses. This one is just Mg3 P2. Crisscross your charges and write them down. So this is magnesium, and this one's magnesium, and this is phosphide, and this is phosphate. All right, almost done here. Ammonium, this is your only positive guy. So ammonium is going to be NH4 +1. It wants to give away 1 electron. Now this is nitrogen. So this is nitrogen right off the periodic table. Nitrogen's in group 5. It needs 8 electrons. So nitrogen's going to gain 3. So ammonium says take 1. And nitrogen says I need 3. That's not enough. So ammonium says we'll go find some friends. So we need 3 ammoniums to hook up with 1 nitrogen. Notice what's happening to the charges here. The 3 gets written after the ammonium, so we're going to put it in parentheses, and the imaginary one gets written there. So this is ammonium, and it's nitrogen off the periodic table, so it's nitride. Change the ending to ide. It's not nitrate, because it's not a polyatomic ion. It's just nitrogen off the periodic table. Now barium's hooking up with acetate. So barium's +2 because it's in group 2. And acetate is one of those, you don't have to memorize it, but you do have to look it up. It ends in 8, so right away it tells you that it's a polyatomic ion. There's some oxygen bonded to it. And overall, this group here in order to stay together, needs 1 extra electron. But barium's saying, hey, take my 2. And acetate says, well, I can only take 1, but I'll go find a friend. So when we crisscross our charges here, that 2 is going to be written after the acetate, and the 1's getting written after the barium. So it's Ba with imaginary 1, and then acetate, C2H3O2, that's my group, and I want 2 of those groups, so I put it in parentheses with a 2. So my name, barium acetate. Okay, so review your polyatomics, know the 7 that you have to memorize, and know any other time you come across an 8 ending that you just need to go look it up somewhere.